Hello, grade 12s. How are you? Today, this is Patrick Kamala once again. Yeah, today I want us to do this combo about the number patterns, and our target is to do question 1, 2, and 3 for the trials, okay, including November 2024 and then May, June 2025. Now, before we do our trials, we want to see last year these learners. What are they supposed to do for question 2 and 3? All right, so as we do this, please try to understand how we do them so that you can also use the same understanding to do your November exam. Okay, so to question 2, they say the first term of arithmetic series is 7. Okay, all right. And then the common difference of the series is 5. And the series contains 20 terms. Now, the more they talk about arithmetic series, we know it's a common difference. Ne? So the first term, which is our A, is 7. So our A is 7, okay? And then the common difference is 5. So 5 is our common difference, okay, for the arithmetic. And then it contains 20 terms, meaning our N is 20. Then they say that calculate the sum of the series. Calculate the sum of the series. So we need to find the sum of the first 20 terms, okay? S20. Now, arithmetic series, we have got two formulae depending on what we have. If the question gives us the first and the last terms, we use Sn equals to n over 2 into a plus l. However, like here they give us the common difference now, so we are going to use our Sn, okay? This gets okay, Sn, our Sn equals to n over 2. Our Sn equals to n over 2 into where we have our 2a, okay, plus n minus 1, then times common difference. Okay, so in this case, we're looking for the sum of the first 20 terms. Né? So our S20 is going to be, we're going to have this is 20 here over 2 into 2a. Our a we see it is 7, okay, that is 7. And then plus n. Now our n is the 20 term, that is 20 minus 1, which is 19. And then common difference, we see it is 5 here, so times 5. In this case, we get our answer here. Calculators, what do you get now? Calculators here, if I use my calculator, it gives me 1090. 1090. Then question 2.1.2, they say the original arithmetic series is extended to 75 terms. So now there are 75 terms in total. The sum of these 75 terms is 14400. So meaning S75 is this one here. And then that is S75, okay. And then they say here that using sigma notation, okay, write down an equation for the sum of the terms added to the original series. So the terms added to the original series, they're going to be how many? Now that we have the 75 in total, how many times were they before? Before they were only 20, so minus 20, which means we are adding how many terms? We're adding 55 terms, okay? So now understand that with the sigma notation, that the understanding or the concept, this is you must know your Tn. You must know your general term, okay? Now this being arithmetic series, how do you find the Tn? Our Tn for arithmetic series, we know it's given by what? Is given by Tn, okay, Tn equal to A plus n minus 1 times D, okay. So in here, our first term they gave us was 7, okay, that is 7 there. Then plus the n minus 1, common difference, it is 5, right? It is 5 here. So it's gonna be 7 here. Now 5 times n, that is 5n, right? Then minus a 5, which is gonna give us a 5n here, and then plus a 2. Plus a 2 here. So it's gonna be our Tn, okay? Now, I don't want to confuse Tn with I better use it as Tk. If I say Tk, it sounds bad. So I'm going to say 5k here, then plus 2. Okay, so now the question says that using I write it as a sigma notation. Now, sigma notation is the summation, okay, of this term. Now, there are 55 terms which I want to represent. So I'm going to begin from what? From the 21st term, up to what? Up to the last time, which is 75 in this case, okay? 75 here of the tk, of this tk, but my tk is what? That's 5, okay? 5k plus what? 5k plus 2, right? Plus 2. Then now this summation must give me the difference here. So here the total was what? Was 14400, but the first 20 times gave me this sum here. So it means that I must subtract here. I'm gonna say 1 4. Yeah, I have to say the 1 4 what? 14400 minus 1090. So calculators, if I do it here, it gives me 13310. 13310. So this is my sigma notation. Hope we are together. All right, let us continue here. They say here that now another question. Now, the sequence of the first differences of the quadratic pattern is what? 1, 3, 5. Okay. So now the quadratic number pattern, you guys know that we have got a constant self difference, right? So for this matter, but if this was the quadratic number pattern in question with our T1 here, all together, and then our T2, and then our T what? Our T3, okay, and then our T4, right? Yeah, and then so in this case, these are differences which they said here. This here, the first differences, ne? Okay, so they mean that when I say T2 minus T1, I'm gonna get a 1 here. When I say T3 minus T2, I'm gonna get a 3 here. And when I say T4 minus T3, I'm gonna get a 5 here. Now, being quadratic, I can go ahead to say 3 minus 1, I get a 2 here. What about 5 minus 3? I also get a 2 here. So this 2 is my second constant difference, okay? What am I supposed to do here? They're saying that if T99 of this quadratic pattern is what? Is 9632, calculate the value of T98. So I'm dealing with the T99 and T98, which means somewhere here, I have my T98, okay, and then T99, okay. Now from here, now when I subtract here, what comes here? Now what we have here is the first differences, ne? Now to avoid confusion, I'm gonna say that for this one, I'm gonna call it Tn, okay, Tn. Then for this other one, the first differences, let me call them what? Let me call them a small tn to avoid confusion, okay? Small tn. Now let me get my tn here. So my small tn from here, my small tn, it is linear now, ne? It's gonna be the first term, which is the 1 here. We saw that 1. Then plus n minus 1, okay? Times common difference, which is a 2 here, okay? So that is a 2 here. So you see it gives me 2n, it gives me 2n, and then 1 minus 2, then minus 1 here. So that's my tn here. So this tn is for this one here. Now, not something here. Take an example here, something, guys. You see, if I talk about T4 minus T3, it gives me this value here. I repeat, if I say that what? That is T4, which is for the quadratic, T4 minus T3, okay? Look at how they are related, equals to this number 5 here. But 5 is which? T small t1, what? Small t, small t1, small t2, small t3, equals to small t3. Are we together? Now, likewise, we talk about T99, okay, T99 minus T98, okay? It should give me the small t what? Small t98, okay? So now I'm going to substitute. Now they said that this one is T99, this one here, T99. I'm looking for T98. So the T99 is what, guys? We see it is 9. They say it's 9. 6, okay, 6, and then 32. I'm looking for T98, okay, T98. Now to get smaller T98, list I'm going to put in here. I'm going to have the 2 times 98, okay. We said here minus 1, so minus 1 here. So from here, if I do my calculations properly here, I can see that it's going to be the 961,932 minus this side. Now the 298 times 2 minus 1, it gives me what? It gives me 195. 195 here, okay? 195 equals to 8, okay? So T98 here, I'm getting now what? I'm getting it as 99437. 9483 and a 7. That's our T98. Okay. Hope we are together. That's that one there. Then let us continue. That is question 2.2.1. Now they say if it is further given that the third term is 32, determine the general term Tn of the quadratic number pattern. Now we know that if we have a quadratic number pattern like this here, and we want our Tn, there's something which we always use, and I hope you know that. Okay. Now our quadratic, now the capital T, that's not the big T. Our big T, this is 2.2. Okay. Now our big T n quadratic equals to n squared altogether, n plus what? Plus bn plus c, right? Whereby this a, we use 2a equals the second difference where it is this 2 here, so equals to 2. That gets my a equals to 1. Then if I have the first difference here, which is 1, I know that also that my 3a plus b, equals to d1, whereby in this case is this one here, Okay, so I'm gonna say 3a. Now I know the 8 is what is 1. I can get this b here by saying equals to 1 here, and then 1 minus 3, so my b becomes negative 2. Now they said that if it is further given that this third term T3, that's capital T3, the capital T3, 32. So I'm gonna get mice using that now. I know that because I know the A and B so far so good. From here now, I can come back and set my Tn, okay, so far. The A, I know it is 1 equals to n squared. What about B? Minus 2n, and then I don't know the C yet, okay? I want to find this C here. So I'm going to say that the T3, which they have given me now, equals to 3 squared here, okay? Minus 2 times 3, okay? And then plus a C, which I'm looking for, should give me the 32 we're talking about here. So this is 9 here, 9 minus 6, okay? And then plus C gives us 32 here. So what do we do here? 9 minus 6, it is a 3. Then ours becomes 20 what? 29. Okay, so here 29, and therefore the required Tn for 2.2.2, because we have the A, B, and C, is going to be our Tn equals to A, which is 1n squared, okay? And then minus 2n, okay? And then plus what? Plus 29. All right. Hope guys we are together. If we are not together, you can inbox me on my number here 0785 for more information. Then last year also, their question 3, it is this one here. They said that a circle with a radius 6 centimeters is drawn. A second smaller circle is drawn. So the first dot is big one. The dot is first one, and the sign the radius is what? Is 6. So meaning from here to here it is 6. Okay. This is 6 centimeters. This is 6 centimeters, okay? And what happens next? Then they say a second smaller circle, now this add-on here, is drawn through the center, it's passing through the center. together. So now, and it is touching this other circle internally. All together, it's touching the first circle. It's touching the first what? The first circle internally. Meaning from here to here must be 6. But because I'm talking about radius now, it's going to be how now? 6 divided by 2 is going to be 3 here, right? 3 centimeters. And then a third smaller circle, so they continue like this again, passing through the center of the second one, the second circle. This is the center here now. So this one must be 3. Then divide by 2 to get my radius. It's gonna be what? It's gonna be 3 divided by 2. It's gonna be 1,5, 1,5 centimeters here. Okay, so what must we do? They say here that write down the radius of the third circle. So our radius of the third circle, as you see, is gonna be 3 divided by 2, which gives us what? 1,5 centimeters. Then they say calculate the sum of the areas of the first 10 circles. Now, what do we see here? What do we see here? What do we see here? We can see that this radii, okay, the radii, how do they go? The first one is 6, ne? The first one is 6, okay, and then followed by which one? Followed by 3, and followed by 1,5, ne? Okay, and so on. Okay, that's for the radii. Okay, but then the question talks about area. So now the areas, okay, they're gonna be now, how do you find the area of the circle? It is pi r squared. It's gonna be now pi 6 squared, and what is 6 squared? It's gonna be 36. It's gonna actually be 36 pi, then followed by pi 3 squared, 9 pi, okay, 9, and so on. Okay, so here they say I want the sum of the first 10 circles, ne? So this is my T1 now for the areas. This is T1 and this is T2. So because I know my A, which is this one here, my A here, I can also get my common ratio by saying T2 divided by what? Divided by T1. So here T2 is 9 pi, okay, divided by 36 pi, which gives us 1 over 4. Okay, 1 over 4 here. Now I'm looking for the sum of the first 10 circles. So looking for S10, meaning I'm gonna say the formula says this, it is A into 1 minus common ratio power what? Power n divided by 1 minus r, all together. So talk about this is Sn. So S10, I'm gonna substitute now. So my S10 is going to be, what is my A? It is 36 pi, okay, 36 pi here, then into 1 minus common ratio, which is what? 1 over 4, okay, the 10 times, so power 10 here, then divided by 1 minus common ratio, which is what? Which is 1 over 4. So in here, we are going to get what? Calculators. Calculators, what do you get there? Calculators here, what does it give me? It gives me 150, comma 80, 150. So I get here 150, comma 80 centimeters squared. Now this is some of the first 10. This the sum of the areas of the first 10 circles. That's good. Then they say that which circle has diameter of what? Of 3 over 128. Which circle has this diameter? So diameter is 3 over 128. Diameter is what? 3 over 128. Now if the diameter is 3 over 128, okay, I need to find the radius. So divide by what? By, which gives us what? Which gives us 1 over what? Which gives us 3, which gives me here, if I divide by the radius here, what do I get? Calculator. It gives me 3, okay, over 256 here, okay. But then I'm interested in the circle with this radius now. Now I'm gonna use the radii now, these ones here. I don't use areas now. Okay. So my Tn for the geometric, okay, Tn equals to a common ratio power n minus 1. So here our Tn is the 3, okay, over what? Over 256, and then equals to what? Equals to a, which is 6 here. You can see the 6 there, okay. Then times common ratio, which is here it is 1 over 2, the common ratio. You can see 3 over 6 is 1 over 2, that is 1 over 2 here. And then the power n minus 1. I'm looking for this n here. So if you divide by 6 here, it gives us here divided by 6, it's gonna give us 1 over 5, 512, 512 equals to 1 over 2 to the power of n minus 1. So in here, now this one you can say 1 over 2 with the factor is going to be 2 power 9 equals to 1 over 2 to the power what? The power n minus 1. So because this one is 1 on top here, actually I can write it as what? As I can say over 2 to the power 9 right together. Yes, to the power 9 equals to 1 over 2 to the power n minus 1. So from here you can see that 9 plus 1 gives us n as 10. So it means that cycle must be the 10th scale, which got this radius of what? Of what they can decide here. So that's our answer here, guys. If you have any question, don't hesitate to reach out on 0785 22041. Let us proceed. Yes, now from that November 2024, let us look at and see how these people from Eastern Cape, they are trying their learners to prepare for the final November. This is 2025 trial Eastern Cape question 2, preparing them for what we have just done. Okay, let's see what they think here. They're saying that two learners, Amanda and Leroy, were given a task to come up with any common ratio that would be suitable to calculate the sum to infinity if it is given that the first term is 2. Below are the calculations. Amanda's calculation, we have a equals to 2 and the r equals to 3. The sum to infinity, she gets 2 over 1 minus 1 minus 3, which gives negative 1 here. They say that Leroy's calculation is what? A equals to 2 and the common ratio is 1 over 2. Then sum to infinity is 2 over 1 minus 1 over 2, which gives us 4. They say here that which learner's response is incorrect. Now here, to answer our question, we are going to remember that from the theory of arithmetic of geometry, to get the sum to infinity, the common ratio must lie between negative 1 but less than 1. So this one is not correct. So we're going to say that if they say whose learner's response is incorrect, this one here used bigger than 1, okay, it's not correct. So it means that it must be what? It must be Amanda. So Amanda's response, okay. Explain why. Because the common ratio that she used does not lie between what? Does lie between negative 1, okay, and 1. That's the reason here. Common ratio must be between negative 1 and 1. For example, 1 over 2. This one is correct because her common ratio is what? Is between negative 1 and 1. So that's why she got this answer here. And that's the one who is correct. Okay. So next question here. They said that evaluate the summation from k equals to 1 up to 10 of this 3 over 10 2 into 2 power k. So from this one here, let's first get our what is our common ratio here? We see it is what is it here? This is k here. So our T1, we put k equals to 1 here, it's going to be 3 over 2 into 2 power what? Power 1, and then plus what? Plus 3 over 2 into what? Into 2 power what? Power 2, and then plus 3 over 2, then into 2 power what? Power 3, okay, and so on until the last time, which is what? Which is this one here with n equals to 10. So here, to get our sum here, our first term is this one here, which gives 3 here. Okay, we want to get simplify here. Then our common ratio is going to be what here? We divide here. So this one it is this is 4 giving us 6 here. It's going to be P2, which is a 6 here, divided by what? Divided by 3. Okay, which gives us a common ratio as 2 here. So the sum of the first 10 terms is going to be given by what? This is being geometric. We notice it's given by a, which is 3, into r power n, which is now the 2 power 10. Okay, r power n minus 1. Okay, minus 1 divided by 2 minus here. So it's going to be the answer here. Calculators, what do you get there? If I simplify here, I can see that 3 times 2 power 10 and then minus 1 here. It gives me 3069. I get here 3069. 3069. Okay, that's our answer for 2.2. Then they say here that which term of the sequence will be the first to be less than this one here. Okay, so let's see what to do here. Now this one is what? If you check here, 6 divided by 8, you get what? You get 3 over 4. Okay, what about the next one here? If you check the 9 over 2 divided by 6, it gives you what? 9 over 2 divided by 6. It gives us the same common ratio, which is also 3 over. So that this is geometric. Okay, so now we want to see which one is going to be the first to be less than. So it means we can see our Tn here. Our Tn equals to A, which is 8. Okay. Yes, question 2.3 Eastern Cape. It says that which term of the sequence, this one here, that sequence here, that is 8, 6, 9 over 2, will be the first to be less than 1 over 100. Now this one here, if you check here, if you talk about 6 divided by 8, okay, that is 2 over T1 equals to T3, that is 9 over 2, the same as 4 comma 5. Okay, that is 4 comma 5. Okay, the 4 comma 5 divided by 6. Now they give you the same ratio, which is what? Which is 3 over 4. So this one is geometric, ne? It's geometric. So now our Tn for geometric n is given by what? Tn equals to A R power n minus 1. Okay, so in this particular case, because we want saying which term of the sequence will be the first to be less than 1 over 100, ne? So you're going to look for our Tn here. But our Tn, if we substitute here, our A is 8, okay? Then dot A, which is 3 over 4, okay, power n minus 1, will be less than 100, okay? 1 out of 100. Okay, so from here now, if you divide by 8, 3 out of 4, the power n minus 1, okay? Power n minus 1 less than 100. And this is 1 out of 800 because it divided by what? By 8. So now if we take a log here, if we take log to base 10, we're going to get our log. This n minus 1 is going to be n minus 1, then log of 3 out of 4 altogether equals to log, okay, to log 1 out of 800. Okay, now in this particular case, I'm looking for my n, so I'm going to divide by this, ultimate my n minus 1, okay, n minus 1. Don't forget here it is less than, this less than here, less than that. Okay, now if you divide by this one, which is log base 1 out of 800, divided by the log of 3/4. Now in this case, because if you check this on the calculator, this one here, the log of base 10 3 over 4, it's a negative, right? So being a negative, now the inequality sign must change. So that now it's going to be n minus 1 greater than whatever is going to come out of here because of this one being a negative. So now calculators, if you take my calculator here, and say that log, okay, we say that log, this one here, on top we have log of what? Log base 10 of this one, which is 1 out of 800, isn't it? 1 out of 800, 1 out of 800, and then here, then divided by log, okay, base 10 of what? Of the 3/4, same as 0.34, 0.75, the 3/4, 0.75. So here it gives me 23.24. So it means bigger than 23.24. Now this one is going to be n bigger than, if I add the one, it's going to be now 24.24. But because we're looking for the whole number, what comes after 24 is 25. So therefore, it means that I'm going to take my n to be 25, and so it's going to be the t of 25, okay, will be the first to be less than what? Less than 1 out of 100, okay? Yeah, that's how we do that. And I hope we are together. Let us proceed here. Next question here. They say that Eastern Cape question 3. The following information about quadratic number pattern is given. That's the T2 minus T1, T3 minus T2. Okay, we have them here. Then the first term is equal to 1, okay? What are we supposed to do in this case? They're saying that they gave us the differences there. So let's check here. So if we have our quadratic pattern, which is T1, okay, T1, and then T2, okay, and then T3, and then T3 here. Now they gave us our first term, the T4, so it is 1. I'm going to put 1 here. Now I know that now if I say T2 minus T1, it gives us negative 4. So I'm putting negative 4 here. If I say T3 minus T2, they gave us what? They gave us negative 3. Okay. And being quadratic, I'm going to get a second difference here. Now negative 3 minus minus 4, it gives us positive 1. They say that show that the general term is going by this one here. So our Tn. Now being quadratic here, we know this also D2, which is 1. And then D1, it is negative 1 over 4. And then we know that any quadratic has got Tn, okay, Tn given by an squared, right, plus bn plus c. So our task is to find this general term like this, okay. So but we know that our twice a equals to d2, whereby in this case it is this one here. So our a equals to 1 over 2, okay. After getting the a, to get our b, we use 3a plus b. 3a plus b equals to d1, okay. Now our a, we know it here. It is the 1 over 2, so 1 over 2 plus b equals to d1. What's our d1 here? It's negative 4, okay, negative 4. Then here going to give us 3 out of 2, then plus b equals negative 4. Then the calculators, what's going to be our b here? Now, if you get a calculator properly, and then you compute in here, our b here, it gives us negative 4 minus 3 over 2. It gives us negative 11 over 2. It gives us negative 11 over 2. Negative 11 over 2. After getting the a and b, we can get our c. They said that our fourth term is what? It is 1. This one here. So far, in our Tn, okay, our Tn, the a we know it is 1 over 2. That's 1 over 2, okay, n squared, okay, and the b it's minus 11 over 2n. So we don't know the c yet, né? But because we know the fourth term, which is 1 here, we're going to say t4. So t4 equals to 1 over 2. Then I'm going to say 4 here, 4 squared. And then minus 11 over 2 times a 4. Then plus c. I'm looking for the c here. Now I must equate to 1 because they say that time is 1. That's the fourth term equals to 1. So in here, if I simplify here, 16 divided by 2, I get 8. There by 2, gonna be 22 here, so it's minus 22 here. And then plus c equals to 1. Now my c, 1 plus 22, and then minus 8. So what do you get there, calculators? That is 23 minus 8, which gives us what? Which gives us 15. So here we're going as our c. And therefore, if you check what we have here now, we have the a, b, and c, right? Whereby our a is 1 over 2. You see it here. Our b is negative 11 over 2. And then our c is 15. So we come to this formula here and put in a, b, and the c. You guys can see that in that case, we are getting what they want here. We are getting our Tn equals to half n squared minus 11 over 2n plus 15. Okay, that's it. Then they say determine the value of T16. Now we know the Tn, so you're going to substitute here. So our T16 here is going to be T16 equals to 1 over 2. Okay? 1 over 2, then 16 squared, 10 squared here, and then minus 11 over 2 times 16, okay, and then plus what? Plus 15. What do you get, calculators there? 15. Yeah, it gives me what? Let me check it out here. If I check it out here, I can see that I have 1 over 2 times 16 squared, then minus 11 over 2, okay, into 16, and then plus 15, right? Yeah, it gives me 55, right? So my answer for T16 is 55. Okay, together. Then they say here that which two terms in the quadratic number pattern will you have the difference of 45? Okay, which two terms in the quadratic pattern, okay, will have what? A difference of 45. In other words, when you subtract the Tn minus 1, okay, it should give us 45. It should give us 40 what? 45. Now that we have the general term, which is this one here, which is Tn equals to half n squared minus 11 over 2n plus 15, we can subtract it by putting in n and n minus 1 and equating to 45 and then solving. But that one, it's going to be quite tedious. So to make our things simple, we better use what? We better use the pattern of the first differences. Now the first differences, they have got a general term Tn, which I'm going to call the small tn, right? The small tn, like this, small t, the small tn. Okay, so here we go. Let me first get some space here. Okay, this is very important because it makes things simpler for you. Okay, now if you check what I have here, guys, you can see that in here, this one here, I'm gonna use it now. Okay, so here my t, and I'm gonna put small t in my tn for the first differences, ne? equals to A plus n minus 1 times D. Now in this particular case, my A is negative 4, okay? Negative 4 plus n minus 1. What about common difference? Is this one here, okay? Times 1. So it gives me here what? It gives me negative 4, okay? And then plus n minus 1, which gives me n minus 5, isn't it? That's my Tn. Now note that when I have got the quadratic, the Tn for the quadratic, which is the capital N, together with this Tn for the first differences, there is a relationship, okay? For example, if I say that, because I'm looking at 5, don't forget, if I say that my Tn, okay, minus Tn minus 1, okay, in this case, is going to give me the smaller t. So in other words, I'm going to equate the 45, okay, to the Tn, which is this n minus 5. N minus 5 here. And so, what do I get? I'm going to get this side, I'm going to get what? I'm going to get 50 equals to that n, okay? And so for that matter, yes, and therefore, my answer, which they want, is going to be the t, okay? The t of 51, okay, minus t50, okay, will give me the 45, okay? That's our answer here. That's our answer here. Let us continue. Let us continue here. Next question says that given Sn equals 2n squared minus 6n, calculate the sum of the first 30 terms. So S30, we want S30 here. Now this one is the sum of the first n terms, which they gave us here. So our Sn, don't forget there, Sn equals to 2n squared, okay, minus 6n. So S30, we just substitute in S30 2 into 30 squared minus 6 times 30. Okay, so here I'm gonna get what? Calculator, what do you get there? That is 2 into 30 squared, right? Minus 6 into 30. Here it gives me 1620. 1620, 1620. That's our answer here, 1620. So this is 1620. Then they say here that determine the value of n if Tn equals to what? If Tn equals to 30. The value of n, if Tn is 30, how do I get it now? Now, because I have the Sn, I'm getting my T1. My T1 is the same as S1, because the sum of the first term, which is going to be what? Which is going to be 2 into 1 squared, okay, minus n minus 1. So, the Tn here is 300, so you can say 300 here. Now the Sn is what I gave us here, which is 2n squared, okay? 2n squared, then minus 6n, okay? Then minus Sn minus 1, so open bracket here. It's gonna be 2, open bracket here, I'm gonna say n minus 1, n minus 1 squared, okay? And then minus 6 into n minus 1, right? So close bracket twice here. So I'm gonna get here, it is 2n squared, 2n squared minus 6n, okay? Then minus here, there is a 2, don't forget. What do we get here? Get n squared minus 2n plus 1, right? Plus 1 here. Then minus 6n and then plus 6, right? Plus 6 here. Brackets again. So it's going to give us here 2n squared, right? 2n squared minus 6n. What about here? Minus, let us enter now the 2. It's going to be 2n squared here, right? And then minus 4n, okay, and then plus what? Plus 2, and then minus 6n, then plus what? Plus 6 here. So like terms, this like terms here. Let's check it out. The minus 6n and minus 1 give us minus 8. We're going to have 2n squared, 2n squared, minus 6n, then minus 2n squared, okay? And then plus 4, plus 4n, right? Plus 4, and then minus 2 plus 6n, then minus 6. Now this one must be equal to 300, don't forget, okay? So here, the 2n squares, they cancel out. The negative 6n and the positive 6n, they cancel out as well. So now I'm left with this is 4n, right? 4n minus 2 minus 6, ne? 4n minus what? 2 minus 6. So I've got the 300 here. 300 equals to 4n. Now minus 2 minus 6 gives us minus 8, okay? And therefore, 8 become positive, going to be 308, right? 308 equals to 4n, So divide by 4. Divide by 4. Our n equals to what? N equals to 308 divided by 4, which gives us 70 what? 77. Hope we are together. Let us proceed. Let us proceed. Yes, let's continue, guys. Here, this is from now Gauteng, 2025 trial question 2. As we do this question, please understand how we do it so that you can pass yours on Friday. Okay. Now they say here that the following sequence of numbers form a quadratic number pattern. It forms what? A quadratic number pattern. Then they say that's negative 3, negative 2, negative 3, negative 6, negative 11. They say here that the first differences of the given sequence also form a sequence. Okay. Determine an expression for the nth term of the first differences. Now, the first differences, they've got the nth term. I'm going to call it small tn. Okay. So, note that because they've got a constant ratio, which is the second difference in this case, let us find out. So I'm going to use tn equals to a, right, plus n minus 1 d, okay? But then, to start with, I begin from the quadratic one, okay? The quadratic one here, which was given to me. They said here I have negative 3, right? I have negative 3, and then followed by what? Followed by negative 2, then followed by what? Negative 3 again, okay? And negative 6, negative 3 again, and negative what? Negative 3 again here, and then negative 6. And then lastly, negative 11, negative 11, negative 11. Okay, so here I have negative 11. All right, so now we know that quadratic, you can minus 2 minus minus 3, it gives us what? It gives us a 1, right? Then minus 3 minus minus 2, it gives us minus 1, right? Then negative 6 minus minus 3, it gives us negative what? It gives us a negative 3, right? Gives us what? A negative 3. And then here, negative 11 minus minus 6, it gives us a negative 5. Now, being quadratic, I'm going to say minus 2 minus 1, minus 1 minus 1, it gives minus 2. And then negative 3 minus minus 1, I get negative 2 again. And then negative 5 minus minus 3, I get negative 2 again. Now, the Tn I'm talking about, the first differences, is for this part here. Look here, guys, this one. This part here has got that T I'm talking about, a small tn. So our small tn here in this case is going to be given by tn, okay? Tn equals the first term Now this is my first term here, this one here. That is 1 plus n minus 1, okay? Plus what? Plus n minus 1 plus n minus 1. And then the in this case is what? Is the negative 2, this one here. Negative 2. So open brackets now. What do we get now? Our Tn equals to 1 minus 2n, right? And then plus a 2, which gives us what? Which gives us negative 2n and plus what? Plus a 3. Now that's what they wanted here. So this is the Tn for the first differences. Okay, so we come here and answer the question now. We can answer the question now here. So our Tn is what? Negative 2n plus 3. Negative 2n plus 3. We're going to say here that our Tn for the first differences, okay, that's Tn equals to negative what? Negative 2n plus 3. The next question from Hauteng 2020, they said that calculate the first difference between the 35th term and the 36th terms of the quadratic sequence. In other words, now we'll talk about the capital T, that is the T36 minus T35 minus T35. Please quote me correctly here. Now, this one is down here. This is the Tn. This is for the Tn, right? The small Tn. Now, the one on top, this one here, on top, okay? This one on top here, this one is for the quadratic, and we call it what? We call it the capital Tn. Okay, I'm gonna call it the capital Tn, which is given by what? By an squared plus bn plus c. Okay, given what? By an squared, given by an squared. Okay, given by an squared plus bn, right? And then plus c. Now that's the Tn here. That is for the quadratic, and we want to find out the difference between the T36, okay, minus what? Minus T35, minus T35. Okay. Now note, guys, that there is a relationship between this small tn and the capital Tn. Okay. This is how we state it, that our Tn, okay, minus 1 is given by capital Tn, okay, minus Tn minus 1. Like in this question, my Tn minus 1, okay, my Tn minus 1, if I'm gonna say equals, now the 36, now is the end is gonna be T36 here, T36 here, and then minus T35. Minus T what? T35. As you can see here that where I have n minus 1, I'm putting what? I'm putting 35. So in my small tn, where there is n, I'm gonna put what? I'm gonna find T35. But to get T35, what I'm gonna do, I come back here and put 35. Gonna be now negative 2 into 35, okay? And then now plus 3. Plus what? Plus 3. So here I'm gonna get what now? Calculators. It's gonna be negative 70 here, right? Negative 70 here. 3. Then plus what? Plus 3 altogether. And in that case, what do I get here? It gives me negative 60 what? 67. That's my answer here. Okay, so in other words, if I come back to the question here, I'm gonna say negative 67 is my answer here. So this one equals to negative 67. Negative 67 here. We are together. Now they say that go ahead and determine the expression for the nth term of the quadratic. Now I'm looking for the capital Tn here. This is from Hauteng 2025. Okay. If you can pass this question very well without framework, guys, you will not suffer with quadratic again. Okay. Now we know that the capital Tn for quadratic, okay, the capital Tn for quadratic general term, that's our Tn, right? Our Tn given by n squared, okay, an squared plus bn, okay, and then plus c. So in this particular case, our twice a equals to d2. Now this case, that's what you see here. That's what you see here as what? As this -2 here, ne? So -2, -2 there. So my 2a is -2, and so divided by 2, our a is -1. Okay. Then to get my b, I'm gonna say 3a plus b. 3a plus b equals to d1. Okay. Then my a, after you see it's -1, ne? 3 times -1 here. I'm looking for this b, so plus b here. What about my d1 here? When I come here now, my d1 is this one here, which you see here. That's the first difference, ne? Equals to 1, equals to 1 here. So when I equate to 1 here, and then our b equals to 1 plus 3, which gives us what, guys? Which gives us a 4. After getting the a and b, what else do I know? That the moment you add a plus b plus c, then you get your T1, the capital T1 for quadratic, right? So our a is -1 and our b is the 4, okay? So you can get our c as well here. What is our T1 here? Let's check the question again here. Now our T1 here, if you remember, it is this -3 here. So when I come back and equate -3 equals -3, -3 here. So now -1 plus 4, that is 3. And then the -3 here, okay, at 3, it gives us -6. So our c is -6. And because of this now, our capital Tn, the question one from Gauteng, is given by Tn equals to a, where that's -1, n squared, okay, and then plus bn, that is plus 4n, right? And then our c is the 6 negative, okay? Yeah, that is it, guys. That is it, guys. Hope we are together. If you have any question, don't hesitate to inbox me on 0785 222 041. Let us continue then. Let us proceed. Next question here from how just to do. Okay, so here we have we said here we got -n squared, -1n squared, okay, and then our b was what? Our b was 4 plus n, and then -6. Okay. Now they say here, explain why the sequence will never obtain a contain a positive term. They say here, explain why the sequence will never contain a positive term. Okay. What do we do in that case? Okay, then what do we do here? Let me do it my way. Now, will never contain a positive term, right? So, from above here, our Tn, guys, our Tn is equals, if I can say, -1, open brackets here. I have n squared, right? N squared, and then minus what? Minus 4n, okay? Minus 4n, and then plus what? Plus a 6c. Plus a 6 here altogether. So what I can do here, I can say that this -1, okay, open brackets here, I can say n squared altogether minus 4n, I can say plus a 4 and then plus a 2. Is that fine with you? Plus a 4 plus a 2 here. When I do so, now this part, this one here in blue, this one here, you know it's a perfect square, né? Which is given by what? By n minus 2 bracket squared, ne? Isn't it? I've got here plus what? I've got here plus a 2. Now don't forget outside I've got a negative 1, ne? Okay. Now the negative 1 here. Now first of all, is my Tn here. Now if you check what I have here, inside the brackets, ne? If my n is any number, whether it is positive or negative, I'm gonna get a positive. Now this positive plus a positive, I'm gonna get a positive, ne? And then a positive one will always be a negative number. I'm done. I'm gonna say since one here, which is n minus 2 bracket squared plus 2, okay, is positive for all n values, ne? For all what? For all n values. For all n values, ne? It means therefore our Tn will, or because of negative 1, ne? What is be negative? It will come multiplying negative 1 times the positive, ne? Negative 1 times that what? Times the positive. Okay, that positive value. So what is gives me what? What it gives me a negative. Okay, so that's how we have here. So we can do it any other way, but that's what I have here. Let us proceed with the how 10 question 3. They're saying here that question 3 here. What are they saying here? The graph below shows a dartboard from which relevant circles can be derived. Okay, there is a derivative of the largest circle and then moving consecutively to immediate inward circles is given by by 18 centimeters, 6 √3 centimeters, and 6 centimeters. They said the innermost circle has a radius of what? Of 2/3 centimeters. They say that the areas of this form a converging geometric sequence. Okay, so now from here, observe what I observe here. They said that I start from 18, right? Start from what? From 18 here, and then to 6 √3. Okay, and then to, so if I do like this here, starting with the 8, starting with the 18 here, and then next one is gonna be what? 6 √3, right guys? 6 √3 here, and then I have what is now from there. They give me the 6, okay, and then the next one, the innermost one is gonna be what? It's gonna be this one, which is 2/3 centimeters. Okay, that is 2/3 centimeters. Now this is a radii, okay. This is a radius, okay, and then I want to show that the areas of the circle form convergent geometry. Now, how do you find area guys for the circle? Now area is given by pi r squared. So now if I square here, I'm gonna get pi. Now my radius here is what? It is the 18. Okay, so I'm gonna have now the sequence in terms of areas. Now it's gonna be given by what? In terms of the areas, not given by now pi 18 squared. Okay, because my radius is 18, it's gonna be pi 18 squared. So here I have pi 18 squared. Okay, all together, and then I'm making the series now, plus pi what? 6 √3 squared all together, plus pi, this one here, plus pi, and then 6 √3 squared. Anybody with a calculator can square it for me, and then plus what? This one will be 36. Now go to 6 squared, it's going to be 36 pi all together, and then until the last one there, okay, which is gonna be what? Which is gonna be given by if you say the 2/3 gonna be 4/9, gonna be now the 4 over what? The 4/9, the 4/9 pi as well. Now this is the last area here. Now I want to show that this one is a convergent geometric, so I'm gonna get my common ratio here. So my common ratio here, I can divide what? This one, which is pi what here? Pi, and then 6 root 3 squared divided by this 18 squared pi, 18 squared pi, because geometric. Now this one here on your calculator, what do you get, guys? Calculators, what do you get there? Now here I'm getting 1 over 3. Because of 1 over 3, now for the geometric to be converging, we know that our common ratio, in this case 1 over 3, okay, it lies between -1 but less than 1, and so therefore it's going to converge. Therefore it's going to converge. So this is series forms working. So therefore the series converges, okay, and therefore the series converges because our common ratio, as you can see it here, lies between -1 but less than 1. Okay, let us proceed next. Then what do they want us to do next here? They say that what? They say that calculate the number of circles in the sequence forming the dartboard. Okay, now the number of circles, if I come back to my red eye here, I had 18, 6 root 3, 6 until the last one here. So to know the number of circles, I'm going to go the number of red eye. Okay, if I can know the number of radii, they're going to be equal to the number of the circles. Okay, so because it is geometric, I'm going to get my okay, n for geometry, my tn, that is tn equals to a, right, multiplied by common ratio power n minus 1. Then I'm going to equate to this last radii here, which is the 2 over 3. 2 over 3. What's our first term here? You see it is 18, guys, right? I'm going to say 18 here. Okay. What about my common ratio? Now the common ratio in here, if we happen to divide here, what we get, let's divide here and see. That is, I can say 6 root what? Root 3 divided by 18. So if I divide by 6, it's going to be 3 here. So it gives me what? Root 3 over 3 root 3 over 3. Now give me what? Root 3. I have root 3 here divided by 3. Then power n minus 1. I'm looking at the number of circles equals to 2 over 3. So in here, I can divide by 18, right? I'm going to have now root 3 divided by 3 power what? Power n minus 1 equals to this side. I divide by 18, so it's going to be now 2 over 3 times 18. 3 times 18, what do you get, guys? Calculators. So here I'm going to be left with what? Now I have in here, it is root 3, okay, root 3 divided by 3 power n minus 1 equals to this side. What do I get, calculators? I'm going to get what? Help me somebody. It's going to be 1 over 27. 1 over 27 here. So now I can get now my log, okay? Can I get my log here? Oh, the 27 is somewhat 3 cubed, and this is 3 power 1 here. So I can say this is 3 here, don't forget. I can say this is going to be 3. This is power half, isn't it? Power half here. Then I can say minus 1, right? Because I'm dividing by 3 power 1, minus 1. Then power n minus 1, right? Equals to, now this 27 is somewhat 3 cubed, but if I take it up there, it's going to be 3 power negative 3, right? So from here, now the 3 power a half minus 1 is going to give me negative a half, so I have 3 power negative half, right, into n minus 1 into n minus 1 equals to 3 power negative 3, right? So because now I have the same bases, I can do what? I can simplify like this now. What do I do here? I can equate the exponents, ne? Now listen, this is then I'm gonna now I have, right, open brackets here, into n minus 1 into n minus 1 equals to negative 3, right? Negative 3 here. So divide by that one there, I'm gonna get n minus 1 equals to 3 divided by 0, 5, ne? Isn't it? So my n is gonna be 1 plus 6, which makes to be 7. So there are 7 circles altogether. There are 7 circles. There are 7 circles. Yeah, let's proceed. Question 3.2, Hauteng. Given the series, okay, given the series here, that is 1 times 2 plus 35 times 6 plus 9 times 9, that times 10, plus 13 times 14 plus so many until 81 times what? 82. Write the series in sigma notation. It is not necessary to calculate the value of the series, ne? Okay. So they don't want us to stress somehow, ne? So what we're gonna do here, guys, now we can see that if you look at the way these numbers are, if this is 1, and then after 1, what comes here? This one is 5, ne? What about here? This is a 9. What about here? This is 13, right? What about the one is in blue now? This is a 2, okay, a 6 multiplied by 10 multiplied by 14. Eh? What we observe for the red, that is 1, 5, 9, 13. What do we see here? Okay, I don't want it in red, né? Like this now. It's 1, right? And then a 5, and then what? And then a 9, and then a 13. Okay, 13. What about in blue? In blue, we have what? We have the numbers that is 2, right? We have the 2 here, and then followed by what? Followed by the 6, okay, and followed by what? Followed by the 10, right? By the 10 here, and then 14. So what do you observe here, guys? Now, if I say 5 minus 1, I'm gonna get a 4 here, right? It's a 4 here. What about 9 minus a 5? Also a 4 here. What about 13? It's a common difference of 4. Eh? What about here? If I say a 6 minus 2, also get a 4. And then a 10 minus 6, also get a 4 here. 14 minus 10, also get a 4 here. So, you see, these are all linear. This is arithmetic. If I get my Tn here, what's my Tn here? It's going to be, that is a plus n minus 1 times d, right? Times d, okay. And then what is my a here? It is that 1 there. What about my common difference? It is the 4, right? The 4 here. 1. What is 4 times n? That is 4n, right? 4n. Then minus the 4. So it's going to be 4n here. And then what is 1 minus 4? Minus 3, right? What about this side in blue? I'm going to say again, this is arithmetic, that is a plus n minus 1 times d. But what's my common difference here? Here the a is 2, right? What about the common difference? It is a 4 still, okay? So multiplied by 4 here. So open bracket, that is 4n, then minus 4, So it gives us what here? Now, so it gives us the 4n here, right? Minus what? Minus 2. So in other words, my Tn is this one, the product of these two. Hello? When I multiply this one times this one, I get my Tn. So in other words, the Tn here is a combination, okay, of multiplied. That means 4n minus what? Minus 3. 4n minus 3 multiplied by what? Multiplied by 4n minus 2. Multiplied by what? By 4n minus 2. Multiplied by 4n minus 2. Okay, so now to get arithmetic series, to get the sigma notation, we need the Tn which you see here together with the number of terms. Now to know number of terms, I can use n of these. If I'm going to use the 81, this one here, then I'm going to take this one here. So I'm going to equate the Tn, that is the 4n, right? 4n equals to 8 what? Equals to 81. Okay. So 81 plus 3, it gives us 8 what? It gives us 84, right? Then 84 divided by 4, our n becomes 20 what? 21 terms. So my sigma notation now is gonna be the summation from, okay, up to 21 of this product here. Okay, which says what? Which says the 4n minus what? Minus a 3 multiplied by a 4n minus a 2. Hope guys we are together, okay? That's our answer here. Let us proceed. Let us proceed. Next question here. It says what? Next question here is how to think that in the series that is a plus ar plus ar squared plus so many up to the sum. So our s infinity is what? Our sum to infinity. They have given us 1. Now in the series where the terms are squares of the above series, where the terms are what? Squares of the above series, then the sum to infinity is what? It is 5/6. Okay, so first of all, we know sum to infinity for any geometric given by what? By a, okay, by a over 1 minus common ratio, isn't it? 1 minus common ratio, but it says one equals to 1, okay? So we can say this is equation 1, okay? But then, if we talk about now the squares of the terms, okay, in here, then our common ratio for the squares would be now if it's gonna be 2 minus it's gonna be now AR, but must be squared, because they said squares. Divided by what? Divided by a squared. So what we get here? We're going to get a squared divided by a squared, and so what we get now? We're left with our r squared, okay? Our r squared here, that's our common ratio. But then they said the sum to infinity is what? It is 5/6. Our sum to infinity of the squares now, remember it's given by a 1 minus common ratio. Now in this case it's going to be given by what? What's our a? The square of a, which is just a squared, right? It's going to be a squared divided by 1 minus common ratio, but which is now r squared, okay? Which is now r squared here. But I said that so it should give us what? It should give us this 5/6, that's 5/6. Then now see here guys, we can cross multiply, we can do what? Cross multiply. And in this case I can write my expression again like this. I'm gonna say this is a squared, I'm gonna say a multiplied by a, that's a squared, now divided by difference of two squares. Now I can say a minus r, okay, all together, multiplied by a plus r. I'm using difference of two squares, ne? A plus r, okay. Now this one, don't forget, should give me what? Should give me 5 over 6, ne? Okay, so from here now, you can see from my equation 1 that a over 1 minus r gives me 1. So this one, it should be a 1. So I'm going to put a 1 here. Then I say times a over 1 plus r, ne? 1 plus equals to 5 over what? Over 6, ne? So from here, again, if I go ahead and I simplify here, I'm gonna do what? I'm gonna cross multiply, right? I can actually from this side here, I can see if I bring what here, if I bring what here, what do I see now? I can cross multiply, ne? Can cross multiply. If I do cross, I'm gonna get 6 times a to give me 6a, right? 6a equals to 5 multiplied by what? 1 plus r, ne? Now my question, don't forget, it talks about I should find the common ratio r, ne? So I might to eliminate what? Eliminate the a. So what do I do here? I can open brackets here. I can say my 6a equals to 5, ne? Plus what? Plus 5r. Okay, so now divide by the 6. Divide by the 6 here. Divide by the 6 here. So my a equals to 5 over 6. Okay. Then plus 5 over 6r, ne? But don't forget that our first equation contains the a and the common ratio. I'm looking for the common ratio, ne? So where I have the a, I'm gonna put this part here now. Okay, this part here where I have the a. So in other words, I'm gonna do like this. Remember, it is a over 1 minus r equals to 1. That's what they give us first is a. It is a over 1 minus r, which equals to 1, right? So I can simply say that my a equals to what? Equals to 1 minus r. So because I have a here and another a there, so because I have this a here, I can equate the two. I'm gonna say that 5 over 6, right? Over 6 here plus 5 over 6r equals to 1 minus r I'm looking for. Collect like terms here. I can say that the 5, okay, over 6r plus my r after crossing equals this one here minus 5 over 6. Now simplifying here, if I talk about it's gonna be 5 over 6 here r, then plus again here I can say here 6 over 6r because of the r here equals to, here I can say 6 over what? 6 over 6 here minus 5 over 6, okay. So here, because I have the same base, I'm gonna say it is what is 5 plus 6? I get 11 r, right? Divided by 6. What about here? 6 minus 5, I'm gonna get 1 over 6, In other words, my r equals to 1 over 11, 1 over 11. That's how we get my r which they wanted here. Hope guys we are still together. Yes, now we can say welcome to Limpopo. Okay, this is 2025 Limpopo trial, and let's just see how the question 2.1 is given. -4,048. Next word, three terms of the sequence. Okay, so this is 2.1.1. 2 here, 2.1.1. I want next 3 times, ne? So what we have negative 4, then we have the 0, okay, then we have what? We have the 4 again, then we have the 8 here, okay. So what is 0 minus minus 4? We get a 4, right? What about 4 minus 0? We get a 4. What about 8 minus 4? It's a 4 here. So meaning to get our next 3 times here, we just add 4, right? We just keep on adding 4. We keep adding 8 plus 4. 8 plus 4, what do we get here? 8 plus 4. We're going to get our 12 here. Again, 12 plus 4. We're going to get our 16 here. Then plus 4, giving us 20. So these are the next 3 terms they wanted here. And then they said that they said that they're saying that determine general term of the sequence, ne? Term of the sequence here, that is 2.1.2. So our Tn from Limpopo, how do we find it here? So our Tn equals to the first term plus n minus 1, right? N minus 1 times d. So here, our first term is negative 4. Hope you can see it here. And then our common difference is 4. Okay. So open brackets here. We're going to have our Tn equals negative 4 here plus 4n, right? Plus 4n and then minus 4. So in other words, our final answer is going to be Tn equals to 4n minus 8. That's from Limpopo, question 2.1.2. Then they say here that they say here again that determine the term of the sequence that is equal to 56. Ne? So if which one is n when Tn is 5, 6. So if our Tn equals to 5, 6, if our Tn equals to 5, 6, then what is the n? What is the n going to be? So our n, you're going to say that our 4 here, our 4n minus 8 should give us 5, 6. Ne? To give us 5, 6 here. And then now 5, 6 plus 8, what do you get? Calculators. 5, 6 plus 8, you get 60 what? What do you get? Calculators. You get 64. And then divide by 4 to get our n. So our n is going to be 16. Our n is 16. Or you can say that in other words, that is 16. The 16th term is the term which gives us 5, 6. That's our answer here. Hope we are together. From Limpopo, they said that then calculate the value of the 12th term of the sequence. Now looking for the T12. Ne? Now because we have our Tn here, our T12, just gonna say our T12, okay? Our T12, we're gonna put a 12 where it is n, ne? In here. So it's gonna be given by 4 multiplied by 12, right? And then minus 8, okay? So what is gonna be our T12 now? Our T12, this is 48, ne? Minus 8. What do you get, guys? You get 40. You get 40. That's our answer here for the T12. Then next, also from Limpopo, what are they saying here? They said that now Given the following quadratic sequence, this is quadratic, ne? Calculate value of x and y here. So what do we know about quadratic? Out here. Let's check it out here. We have yeah, we are saying the moment they say it's quadratic, ne? It means what? If they say quadratic, what do we have here? What do we have here? What do we have here? We have, they said x, y, 2 minus 2 minus 8 minus 16. Ne? That's what happens here. So we have x, and then followed by what? Followed by y, then by 2, then followed by what? By negative 2, then followed by what? By negative 8, and then by negative 16. Okay, so here, what do we have here? This is y minus x, ne? Y minus x here, and then 2 minus y, okay? 2 minus y here. What about here? Now, minus 2 minus 2, that's minus 4. What about minus 80 minus minus 2? That's minus. Then minus 16 minus minus 8, that's minus 80. And then minus 80 minus minus 6, that's minus 2. Also minus 60 minus minus 4, also minus 2 here. In the same way here, we must also get minus 2. Okay, so we start by getting, we're looking for x and y, don't forget. Ne? Let's start by getting our y here. I'm gonna say this one like this now. I'm gonna say that here I'll get my y by saying that negative 4, okay, negative 4 minus 2 minus y, okay, should give me negative 2, the second difference. Ne? So here I'm gonna say minus 4 minus 2 n plus y equals negative 2. So in here, now minus 4 minus 2 is minus 6. So our y equals to minus 2 plus 6, ne? Minus 2 plus 6, giving us our y equals to 4. After getting y as 4, we can come to get our x here. We know that y is 4 here, so it's now 4 minus what? X, okay? And here, this y is also 4 here. Okay, so now, don't forget again, we know that the second difference is what is negative 2. So in other words, if I say 2 minus 4, that's minus 2. If I say this, I'm going to say that minus 2, right, is minus 2 now, right? Minus, open bracket, 4 minus x. Okay. I should still get the negative 2 here because it's quadratic, ne? Equals minus 2. So I have minus 2 minus 4 plus x equals negative 2. So in here, the negative 2 and this one, they're going to cancel out. Now the minus 4 becomes positive 4. And that's my x here. That's our x here. So in other words, our x equals to 4. X equals to 4. X equals to 4. X equals to 4. That's what we have here. Then they say here, the nth term of this sequence is 10 equals 1 here. Determine what is A, B, and C. Now that we're looking for the general, ne? Okay, that's not a big deal. We know that very well. Now to begin with, let's first get some space here. Some space here, some space here. We know that our Tn, right, for quadratic, ne, is given by what? By Tn equals to an squared plus bn plus c plus bn plus c. Okay, so we know that our twice a equals to d2. Our d2 is this negative 2 equals negative 2, and then our a will be negative 1. Okay, negative 1. We know also that 3a plus b to give us d1. That's our d1 here, because x is 4, so now b 0 equals to 0 now. Okay, so but we know the a is negative 1, right? B to give us 0. So in other words, our b equals to 3. Our b equals to 3. After getting a and b, talk about now what? A plus b plus c. A plus b plus c equals to t1. Our t1 is x, which is 4. Okay, and then from there we can get what? We can get, we know the a is negative 1, right? It's on here. A is 1, so it's a negative 1 here. What about our b? Is 3. We're looking for the c now. Okay, after equation, and so 3 minus 1, that is 2, and the 4 minus 2, that is also 2. So our values of a, b, and c, our a, we see it is a negative 1. Okay, then our b is a 3, and our c is a 2. That is from Limpopo 2025. Okay, let us continue again from Limpopo. They said that are given 3 times 2 power 5, then 3 times 2 power 4, 2 cubed, and so on. Will the series converge? Give a reason for your answer. Now we said that for convergence, our common ratio must be between -1 and 1. Let's find the common ratio here. So our common ratio here, we can say t2 divided by t1, t2 divided by 1, whereby in this case our t1, our t2 is the 3, okay, multiplied by 2 power 4, okay, 2 to the power of 4, divided by t1, which is what? Which is 3, multiplied by 2 to the power of 5, Okay, so here, if you check here now, what we get here, the 3 is gonna cancel, and get 1 over 2, So because we have 1 over 2, then you're gonna say yes. Yes, it's gonna converge. Why? Because the 1 over 2 is a common ratio, like -1, but less than 1. That's the answer there. They calculate the sum of the past 7 times, so we want S7 now. Now S7, our S7 here, is given by A into 1 minus C R the power 7 divided by 1 minus common ratio. So it's gonna be now what? Our S7 is going to be, what's our A here? It is the 3, open brackets here, 2 the power 5, and that's our A here. Then into 1 minus, that is a half, okay. Then power 7, okay, power 7 here. Then divided by 1 minus common ratio, that's 1 minus a half here. So calculate what we get here to get our S7. Calculators, get me the answer. Calculators here. What here? Calculator. What do you get there? Now here I am getting 0.5. 190.5. Okay. 190. That's here. Alright, then they say calculate the sum to infinity, that is 3.3. Now our S infinity is given by A over 1 minus common ratio. Now our A here, like we said already, it is the 3 into 2 power 5, 2 the power 5 divided by 1 minus common ratio. That is, we said is a half, okay? 1 over 2 here. So calculators again, what do you get there? What do you get calculators here? Here I'm getting 192 as my final answer here. You can check well. Then lastly, they say calculate the summation from k equals to 8 up to infinity of this one here. Pay attention again here. Pay attention. Please, we check what we had here. They say the sum of the first 7 times. Now here we're starting from 8. Okay, and we know we have the sum to infinity. This number here, which is 192, right? So there's something to use here. We should note that actually our sum to infinity. Our sum to infinity, our sum to infinity is given by the summation, are we together, from k equals to 1 for the first 7 times, up to 7 altogether of this thing here, of this Tn here, okay, that is of 3 by 2 to the power what? By 2 to the power 6 minus k. Are we together? 6 minus k. Okay, here the first terms I'm just gonna put there's 7 terms there. I'm gonna put summation of the just for the Tn, right? For the Tn, and then plus this one here, which I want now, summation from k equals to 8, okay, k equals to 8 until infinity, okay, of the 3 into what? Into 2 power 6 minus k. Power what? 6 minus k. Now this one, I know the sum to infinity. I got 192. I'm gonna say 192. 192. Now the sum of the first 7 terms here, we go to what? If we check here, this one here, it is 190.5, so we're gonna say 190.5, 190, a comma the 5, then plus summation, which you're looking for, from k equals to 8 until infinity of this 3 into 2 power what? Power 6 minus k. So from here, because I know these values, therefore, I'm gonna say therefore my summation, right? My summation 3 into 2 power 6 minus k, power 6 minus k up to infinity from k equals to 8, from k equals to 8 is gonna be the difference, gonna be 192 minus what? 190, 5, 5 here, which gives us 1,5 here as our answer here. Yes, now from Limpopo, let us find out those people in Free State, how they did this question about number patterns. Free State question 2/2025. They said here that term of the quadratic number pattern is Tn equals to a squared plus bn plus c, and its first term is 8. The general term of the first difference of the pattern is what? Tk equals 4k minus 2. They say determine the next two terms Okay, so here they give us the first term, that's our T1. They give us our T1, guys, okay? They give us our T1 here. And they said that our T1 is 8, né? This one is 8. So our T1 is 8. And they gave us this one here. The first one says, né? So what do we know? They gave us our, now we know that when you say T2, okay, T2 minus T1, then you get your first term of the first difference, which you call the T small, which I was calling the small T1. Now the small T1, now here because they said our TK, they said our TK equals to 4k minus what? 4k minus 2. 4k minus 2. I'm gonna find now, I'm gonna put a 1 on the k to get my first term here, my thing here. So it means if I say that T2, what's my T1? My T1 is 8, okay? Should give me this answer here. What is 4 minus 2? It's a 2. So my T2 equals to what? Equals to 10. That's 2 plus 8, which is 10. Okay, because they want the next two terms, né? Okay, so now to get my T3, I'm gonna say again T3, okay? T3 here minus T2 should give me now the small T2 here. Okay, so I know the T2 is 10. So T3 here minus 10, okay, should give me the T2, whereby k I'm gonna put a 2 now. That is 4 times 2, right? 4 times 2, and then minus 2 again, giving me T3, right? T3 minus 10. Now this is 8 minus 2, which is a 6, né? Equals to 6 here. Therefore my T3 equals to 16. Equals to 16. Yeah, that is it there. All right, hope we're together now. The two terms which we have got the 10 and then the what? And then the 16. Now they say go ahead and show that the denominator what? Squared minus 4n plus 10. Because we have this one here, we can find our second difference, né? Remember our first term there? The first term is 8, okay? And then followed by what? Followed by 10 together. And followed by what? Followed by 16. By 16 here. And so on. So here, the 10 minus 8, I get a 2 here. And then the 16 minus a 10, I get what? I get 6 here. And then 6 minus 2, I get a 4 here. So in other words, we said that our Tn for the quadratic is an squared plus bn plus c. So we can go ahead now, b and c, okay? Okay, so in that case, we're gonna say here that our twice a is our d2, ne? What's our d2 here? We see it is 4, right? So divided by 2, our a is gonna be 2. After getting the a as 2, to get our b, we said we're gonna use 3a plus b, ne? 3a plus b equals to d1, and that d1 is this 2 here. So equals to 2. And then, but our a is what? Our a is the 2. And we're looking for this b here equals to 2 here. So our b is going to be 2 minus 6, which gives us b as what? As negative 4. 2 minus 6, giving us b as negative 4. After getting a and b, to get our c, we say a plus b plus c, a plus b plus c equals to t1, which was given as 8. But because we know the a as 2, we know the b as -4, we can get our c now by equating to 8, isn't it? So now tell me somebody, what is 2 minus 4? I get -2. I can go over. So 2 plus 8 gives us c as 10. So our c equals to 10 here. Our c is 10. And that is what they want us to show. They say, let's say 2n squared. Yes, so that's how we show it. Now they say, which term of the quadratic number pattern will be equal to 3050? 3050. So now that we have our Tn, let us use it. Let us use it and equate to what? To 3050. So our Tn equals to 3050, but we know that our Tn is 2n squared, and then minus 4n, and then plus 10, okay, plus 10 here, should equal to 3050, 3050. So whereby in here, we're gonna say 2n squared, right, minus 4n, okay, then minus what? 3040, 3040 equals to 0 here. So we can solve this quadratic here. We can solve this quadratic here by to get our n squared. Okay, n squared minus 2n, then minus 1520, 1520 divided by 2 equals to 0 this side as well. So now our n equals to minus b, okay, plus minus what? Plus minus square root of b squared minus 4ac, that's -2 squared, minus 4ac, but the a is what? The a is 1. What about our c? -1520, 1520 divided by 2a, divided by 2a. And so in this case, our n here, it gives us calculators. Here I'm getting 40. I'm getting 40. You can find out. Yeah, I hope we are still together, guys. Let's continue. If you're together, let us proceed. Yeah, all right, guys. Now our task was to do the May-June 2025 here. That's why we have been doing the trial papers for 2025 from different provinces. Let us now find 2025 was supposed to be done for this particular question of number patterns. Okay, they say here that given arithmetic series 579 up to 93, determine general term of the series Pn plus Q. Now here, if we check what we have here now, what is 7 minus 5? That is a common difference of what? Of 2 here. Okay. What about 9 minus 7? Also 2 as well here. So common difference is 2, and the first term is 5. Next, so our Tn here is given by what? By Tn equals the first term, which is 5. Okay. And then plus n minus 1, then times common difference. So our common difference, as you can see, it is a 2, and so multiplied by 2 here. So we're going to have our Tn equals to 5, okay, 5 here, and then plus 2n here, and then minus 2, okay, so the 5 minus 2 now give us a 3, so our Tn 2n plus a 3, which is what? 2n plus 3. So it's our Tn here, 2n plus 3. Okay, then here they said that the given series represents the number of kilometers that an athlete can run each week, that an athlete ran each week in preparation for the ultra marathon. The athlete ran 93 kilometers in the last week. Okay, and then of the training program. Then they say here that how long in weeks was the training program. So here now this was week 1, and then this was week 2, and then this was week 3. Okay, then we want to find out what week number was this one here. Okay, our n for this one, our n is what now? So in this particular case, because we have the tn, we're gonna say that our tn equals to, we got it there, which is 20 plus 3. Now the 20 plus 3, we're gonna equate it to the last what? The last kilometers, which is 93 here, to know the week number. Okay, so here now 93 minus 3, we're gonna get 90, and so for that matter, our 2n equals to 90, then divided by what? Divided by 2. So giving us our n as what? 45, isn't it? It is 45 here. And then it means that this program was for how many? 45 weeks. 45 weeks. Okay, in total. Then they say here that so yeah, our n is 45 weeks, 45 weeks. Then they say here also, they said that the athlete used this opportunity to raise funds for her high school. Okay, and then they say the community sponsored her 10 rands for each kilometer. So when you run 1 kilometer, you get 10 rands. Okay, during the training program. Then they say calculate the total amount of the athlete raised for her school. Okay, so to get the total amount, it's better to get the total kilometers run. To get total kilometers run, we're going to find the s of the so we know that because we have the this was last week you ran 93, and this one being arithmetic, and we have the first term as 5 here. So the best way to do our sum here, we are going to use Sn. Okay, we can use our Sn here. You can say that our Sn is given by what? Is given by the n over 2, the into the first term, which is a, and then plus last term. Okay, divided or a close bracket. So here now the sum of the kilometers run in the 45 weeks. Let's going to have the sum of the kilometers run in the 45 weeks. That's S45. Okay, S45 here, then equals to 45. Okay, equals to 45 here, divided by 2, right? Divided by 2, open brackets here. Now in the first week she ran only 5 kilometers, gonna be 5 here, then plus 9 what? Plus 93 in week 45, 93 here. So if you check here with the calculator, what do you get? Here I'm getting 2205. I'm getting 205 kilometers in total. Now don't forget that these are kilometers in total, but then the community was giving her 10 rand for each kilometer. So the amount she must have received is we're gonna multiply the 10 rands, okay, times number of kilometers, that is times this value here, times the 205. In that case, this girl, she got how much? She got this rand is here, that is 22055 2,250 rands, okay? That is 22,050 rands, okay? That's what she got in total for her school fees, okay? Let us continue here. Next question here. Don't forget that we have been trying other trials because we wanted to do this one, which is the national paper. Now they say here that the general term of the geometric sequence Tn equals to 2 power n plus 2. Write down the first term. So you're going to use our n equals to 1 to get our first term here, T1. So our T1, which is the first term T1, equals to, here we have a 2, the power plus 1 plus 2, 1 plus 2, which gives us a 2 power 3. And 2 power 3, we know it is 8. Ne? So the T1 must be 8 here. They said the common ratio. Now the common ratio, we're going to divide our T2 by T1, okay? T2 by T1 here. And then our T2, we use n equals to 2. So that'll be 2, the power 2 plus 2, 8. And then divided by our T1, which is 8 already here. Or you can say 2 power 3. Okay, so here, this is 2 power 4 divided by 2 power 3, which gives us 2, which gives us a 2. So the common ratio is a 2 here. It is a 2. Then look at T20. Write your answer as a power of 4. Okay, now the T20, meaning our n is 20, right? So we're going to say here 2 to the power 20 plus 2, 20 plus a 2, which gives us what? Which gives us a 2 to the power 22. Okay, power 22 here. And they said power now 4 is the same as 2 squared. So if I'm going to say 2 squared here, and then I take out a 2 from that side. I should say 20 divided by 2, which is 11. So, and 2 squared is the 4. So it's going to be 4 to the power 11, right, guys? 4 to the power 11 here. That's our answer here. Then they say calculate the sum to infinity 1 over Tn. Now 1 over Tn to infinity. Let's find out here then. So 1 over Tn to infinity. So that's what we're looking for. What do we do here? We're going to set that our T1, okay, our T1 plus T2, and then plus T3, okay, until infinity. Until what? Until infinity. Okay, so in here, we're going to have our T1 1 over Tn, eh? That is the 1 over 8, which is 1 over 2 power 3, okay. And then the next one there, it is plus 1 over 2 power 4, right? 1 over 2 power 4, when our n equals to 2. 1 over 2 power 4, okay. And then next there, now n equals to 3, 1 over 2 power 5, okay. 1 divided by 2 power 5, and so on. So now from here, we can get our common ratio. Can get our common ratio here. We know that common ratio is given by what? Is given by T2 divided by T1. T2 divided by what? By T1. So in this case, our T2, this one here, divided 1 over, that is 1 over 2 power 4, divided by what? Divided by 1 over 2 power 3. So multiply together the reciprocal time was 2 power 3 over 1, 2 power 3. That's the reciprocal to change from division, okay? So our common ratio is going to be 1 over 2. Now, because we're looking for the sum to infinity, now our sum to infinity here is given by A over 1 minus common ratio. 1 minus common ratio. But our A here is this term here, 1 over 2/3, 1 over 2 power 3. We can say 1 over 8. Okay, 1 over 8 divided by 1 minus common ratio 1 minus a half. Okay, so in this case, calculators, what do you get there? Calculators, what do you get here? Calculator, what do you get here? Okay, what do you get, calculators here? What do we get here? Calculators here, I'm getting 1 over 4. I'm getting 1 over 4 as my answer here. I don't know what you're getting that side. Is what I have. Now they say I'm on 2.2.4 that consider first 21 terms of the sequence, then calculate the sum of the terms in this sequence that are not powers of 4. Okay, so what we are going to do here now, we are going to separate them like this. Let's get some space here that are not powers of 4. So we can move like this, that are not powers of 4. Okay, they say consider the first 21 terms. You're going to say here, you can say that T1, okay, T1, you can say T1 plus T2 plus T2, and then plus T1 plus T3 plus T3, okay, and then plus T4. You're going until 21, and then plus T5, plus T5 here, and then plus T6, and so on until plus what? They said consider the first 21 terms until T21, okay? Until T21. Now they say here that they want the sum of the terms that are not powers of 4. So in here we put our formula. Remember we are having starting from 2 power what here? That's from 2 power 3. This which was the 8. Remember that? This one here. It was 2 power 3, which is 8, then 2 power 4 like that, okay? So starting from 2 power 3, what do we see here? Starting from 2 power 3, so we have here 2 power 3, right? And then plus 2, okay? And then plus what? Then plus 2 to the power 5, okay? Power 5, and then plus 2 to the power what? 2 to the power 6, right? Are we together? And then we have so many plus 2 power 7. They continue plus 2 power 7 are together, and also you can say plus 2 power 8. There are so many terms here, but our interest, we're looking for those terms which don't have what, which are not powers of 4. So last time here when you use 21, you get 2, 3. Now we are adding 2 between 3 here. So now those terms which are not divisible by which are not you can put them in red here, like you can say this one here is not a power of 4. Actually, all these those one with all the powers, they want to be powers of 4 until the last 2 power 23. Okay. Now if you check here, because this was geometric, you can get a common ratio here and a common ratio here, which is very common. So now the 2 power 5 divided by 2 power 3 will give us a 4. Okay. What about here? 2 power 7 divided by 2 power 5 is also going to give us a 4. So that's our common ratio here. Now we need to know the number of terms before we get the sum of these terms. So to get number of terms here, we can use our Tn, okay, equals to A, or Tn equals to A times common ratio power n minus 1, okay, whereby our Tn now is going to be this 2 power 23. So we can say that 2 power 23, 2 power 23, okay, is equal to our A, which is 2 power 3, that's our A 2 power 3, multiplied by common ratio, which we got as 4, right? Then power what? Power n minus 1. We want to know how many terms are they, which are not divisible by, which are not powers of 4. So here, divided by 2 power 3, I'm going to get 2 power 20 now, right? 2 power 20, and then equals to 4, which is almost 2 squared, okay? 2 squared here. But up there I have what? I have n minus 1, okay? Because I have the same base now, 20 divided by 2, I'm going to get a 10 here, okay? 10. And then this 10, I'm getting the exponents now, equals to n minus 1. So what's n plus 1? 11. So my n, the number of terms is what? Is 11, okay? 11 terms. Now that I know the number of terms, I'm talking about geometric. How do you find the sum of geometrics? Sn equals to A into 1 minus common ratio, right? 1 minus common ratio power n divided by, now the sum of the first 11 terms which you're looking for, that's S11. You're going to use our A. Our A was this one here, which is 2 power 3, that's 8. That is 8 into 1 minus the common ratio, which is 4, 1 minus 4, then power 11, the 11 terms, divided by 1 minus 4. Yeah, what do you get calculators here? What do you get now? Calculator, what do you get calculators? Here, I'm getting I am getting 1 1. Yes, I'm getting here 1 1. That triple, then with 8 4, okay, and then 8 0, 8 0 8. All right, so that's what we have here. That was May June 2025, this very year. Question 3. Let us see. They say here that given the quadratic sequence on here, the one general sequence 10 equals to n squared minus 18 plus 21. So that's what we want to show. So we know this very well, ne? We have tried a lot, ne? We have tried a lot of trials for 2025. This one will not fail us, ne? So note that we have the 14, then followed by what? Followed by 9, and then by what? Followed by 6, okay? Then followed by what? Followed by 5, okay? Now this is quadratic, this is quadratic here. So we're gonna say, what is 9 minus 14? What's 9 minus 14? Negative 5, isn't it? What about 6 minus 9? Get negative 3. What about 5 minus 6? Get negative 1. Then negative 3 minus minus 5 to give 2. And then negative 1 minus 3 gives us a positive 2. So then you're going to say that, remember our Tn, not our A, equals to D2. And our D2 is the second constant difference. In this case, it is a 2. Okay, so divided by 2, our A becomes what? Our A becomes 1. And then to get our B, is 3A plus B. 3A plus B equals to D1. In this case, our D1 it is negative 5 here, so it equals negative 5. So, but we know that our A is a 1, so 3 times 1, 3 times 1 plus B to give us what? To give us negative 5. Give us negative 5. So, now the 3 becomes a negative, né? So, our B equals negative 5 minus a 3, which gives us negative 8. After getting A and B, we need to get the C as well by saying A plus B plus C. A plus B plus C equals to T1. Equals to T1 here. T1 is what? Our T1 given here, we see it is 14. So our A, which is a 1, what about B? Minus 8. What about the C? That's what we're looking for. And then the T1, up we see it is 14, right? 14 here. So then finally, our C calculators, what do you get here? 14 plus 8 minus 1, it gives you 21. And so our T minus 8n plus 21 is required there. Now this is something here very important as we conclude. They say that the two consecutive terms of the quadratic sequence have a difference of 33. Then they say, you know what? Calculate the value of the larger term. I repeat, they say that the two consecutive terms of the quadratic, this one here, this one here, this one here, have a difference of 33. Calculate the value of the larger term. Now, to make our things simple here, what we can do, we can use the smaller tn I told you about, whereby we are gonna do like this now. We can say, consider this one here like this now, this one here, together with the 2 as the common difference. When we do so, our tn equals to what? Equals to a plus n minus 1 times d, equals to a plus n minus 1 times what? Times d. Times d. So in here, n is going to be what now? Who can tell us here? How small tn? Now our a is what you see as negative 5 here. So it's going to be negative 5 there. Okay, negative 5. What about our common difference? It is common difference is what? It is these 2 here, these 2 here, right, guys? So times 2. Now our small tn here. Now, guys, what is 2 times n? Get 2n, isn't it? What about negative 5 minus 2? What do we get? Get negative 7. Now, note that after getting your tn, there is a relation between the small tn and the capital Tn, this one. The tn minus 1, okay, is the same as subtracting the capital Tn and then minus what? Minus Tn minus 1. Minus what? Tn minus 1. So in here, because they gave us the difference as what? I think they said it said something here. They said it's 33, which is 33. You can see it here. It's 33 here. So we're going to come here and find our n minus 1. Okay. So because we have the Tn here, which is 2n minus 7, then our Tn minus 1, we're going to equate it to the 30 what? To the 37. Okay. And then you're going to solve 2 into n minus 1. I get 10 minus 1, n minus 1, right? And then minus a 7, okay? minus a 7 here equals to, here they gave us 33, not 37, sorry. They gave us 33. If you check here one more time, this is not 37, eh? It is 33, right? So I'm gonna say here 33. Now 33 plus the 7, it makes 40. And 40 divided by 2, you get 20. So minus 1 equals to what? 40 divided by 2 equals to what? Equals to 20, right? Equals to 20. Equals 20. And so for that matter, our n equals 21 equals 21 equals 21. And so because of that, what do we say? We said that you can do what? You can find the other one, okay? You can find what? The other one by using Tn minus 10 minus 1 equals what? Equals 33. So for this matter, because our n is 21, so that now here, which one is bigger, guys? Tell me, talk to me. Which one is bigger? Talk to me now. Which one is bigger? Is it Tn or n minus 1? Which one is bigger? Common sense. Of course, the Tn is bigger. So it means that I'm going to find the T21. T21, my n is 21. I'm going to find T21 now. So T21 will be given by what? Now here we use now the big Tn. Okay. So it is n squared minus 8n plus 21. So we're going to say here it's going to be 21 squared, right? 21 squared. 21 squared, right, guys? And then minus 8n, but our n is 21. And then what? Plus 21, right? Plus 21 here. What do we get now? So here, calculators, what do you get? Calculators, here I'm getting 2, 9, and F4. That's what I'm getting here. All right, guys, I think we have done enough. Now the rest is for you to go and practice more and more and more to avoid practicing the exam on Friday. Thank you. Bye-bye.